Hello friends, welcome back. In the last session we have looked into limit x tends to a x to the power of n minus a to the power of n by x minus a equal to n into a to the power of n minus 1, where n is a positive or negative integer. So we have looked into those two scenarios. Now let us see if n is a rational number, then is this formula holds good or not. For that, what we will do, we already know that the limit of x to the power of n minus a to the power of n by x minus a is equal to n into a to the power of n minus 1 for integers. So I will try to convert the rational number into integers so that we can apply the formula whatever we know earlier. Before that, let me just take let n equal to p by q, which is a rational number where p, q are integers and q greater than 0. So I can write this as limit x tends to a, x to the power of n is nothing but x to the power of p by q minus a to the power of p by q by x minus a. Now we know that when it is positive integer power, when the x to the power of power is positive integer, we know how to apply the formula, because we know that that holds good for, and it's nothing but equal to n into a to the power of n minus 1. So we have to convert this rational number into a positive power. That means I have to substitute x with some other value. For that, what I will do, I'll do a small work here. I will say x to the power of p by q is nothing but x to the power of 1 by q whole to the power of p. Now you can see I have made p by q as 1 by q whole to the power of p, where p is a positive integer. So if I can substitute x to the power of 1 by q as something like y, it becomes y to the power of p. Then I can apply the formula whatever we know earlier for positive integers. So what we will do, we'll do substitution. We will say let x to the power of 1 by q equal to y, and also a to the power of 1 by q equal to b. So what happens now? This becomes x to the power of 1 by q whole to the power of p minus a to the power of 1 by q whole to the power of p divided by x minus a. I have to say limit x tends to a. That's mandatory. Without that, it's meaningless. Till you substitute, you should always say limit x tends to a. Okay. What will be the next step now? We know x to the power of 1 by q is nothing but equal to y. So I can write it as y to the power of p minus b to the power of p divided by, what is x? What is x? X is nothing but equal to y to the power of q. How we know that? If x to the power of 1 by q equal to y, then x to the power of 1 by q whole to the power of q is nothing but equal to y power q. Or can I say x equal to y to the power of q. Now using that, I can write this as y to the power of q minus a, I can write it as b to the power of q. Now you know that as x tends to a, y should tend to b, and there is limit. Now this is nothing but equal to, if you observe, this is nothing but in the form of x to the power of n minus a to the power of n without x minus a. We don't have x minus a, but we have x to the power of n minus a to the power of n. Similarly, in the denominator also you can see Again it is in the form of x to the power of n minus a to the power of n, and you can see for both of them the x minus a is nothing but equal to y minus b. So what I will do, I will try to convert this into the form of x to the power of n minus a to the power of n by x minus a. For that what I will do, I will write it as limit y to the power of b. This is nothing but equal to y power p minus b power p by y minus b divided by limit y tends to b, that is nothing but equal to y power q minus b power q by y minus b. I hope you are okay with that. What I have done is nothing. I have made the division of limits as limit of divisions, limit of quotient as quotient of limits, and I have added the term x minus a, which is missing in both of these. So now if you simplify that, it will be nothing but equal to the earlier one only. Now this is simple now, because you know what is the value of y to the power of p minus b to the power of p by y minus b is nothing but equal to in the form of x to the power of n minus a to the power of n by x minus a, which is equal to n into a to the power of n minus 1. So it will be nothing but equal to p into b to the power of p minus 1. Similarly, in the denominator I will have q into b to the power of q minus 1. So this is nothing but equal to p by q into b to the power of p minus 1 minus of q minus 1. That is nothing but equal to p by q b to the power of p minus 1 minus 1. Let us simplify that. P minus 1 minus of q minus 1. So that is nothing but equal to p minus 1 minus q plus 1. So minus 1 plus 1 cancels. I have p minus q. But we are interested in p by q, correct? So what we will do now, we will convert b again back into a. That is where we started our problem. The problem is x to the power of p by q minus a to the power of p by q. So my answer should be in terms of a, actually in terms of a. So what I will do now, I know that b is nothing but equal to a to the power of 1 by q. So I can write it as a to the power of p minus q whole to the power of 1 by q. I hope you are okay with that. That is nothing but equal to p by q is again n and a to the power of, okay, maybe I missed one step which may confuse you, so let me just write it down. If I simplify this, this is nothing but equal to p by q into a to the power of p by q minus 1. But we know that p by q is nothing but equal to n. So I can write it as n into a to the power of n minus 1. So we have successfully proven that even for rational numbers, the x to the power of n minus a to the power of n by x minus a, for either it is positive integers or negative integers or rational numbers, the formula holds good. Now let us just try to summarize before we do couple of simple examples based on that. So we are trying to prove that x to the power of n minus a to the power of n by x minus a, limit of that as x tends to a is equal to n into a to the power of n minus 1 holds good when n is a rational number also. So for that we have taken n equal to p by q. Now we know that x to the power of n minus a to the power of n by x minus a holds good when n is integer. So we have substituted x to the power of 1 by q, where I am having the power in denominator. I have just converted that into another variable y, so that I can have positive powers. Now after that we observed that we are having x to the power of n minus a to the power of n again in the form of x to the power of n minus a to the power of n in the denominator, but missing the x minus a term. So we have deliberately added the x minus a term that is nothing but y minus b. We have added that so that we can apply the formula whatever we know for positive integers. Now once you simplify that, you will get p by q b to the power of p minus q. You convert that into a, it will become p minus q by q. Now you can substitute p by q equal to n, back substitution will give you, that's nothing but equal to n into a to the power of n minus 1. So let us do some simple examples to just apply the concept what we have learned just now. Let us take a simple example. Just now we have learned about rational. So I'll just go ahead and do one simple problem with respect to rationals. What we will do is, let us say limit x tends to a, x to the power of 2 by 7 minus a to the power of 2 by 7 by x minus a. This is what is given to us. Now this is in the form of x to the power of n minus a to the power of n, where 2 by 7 is nothing but equal to n. So we can directly go ahead and write down the formula. That's nothing but equal to n is 2 by 7 into a is a only, to the power of n minus 1, that's nothing but equal to 2 by 7 minus 1. So that is nothing but equal to 2 by 7 into a to the power of 2 by 7 minus 7 by 7, that is minus 5 by 7. Let us do one more problem. Let us look at this example. Limit x tends to a, x to the power of 2 by 3 minus a to the power of 2 by 3 by x to the power of 3 by 4 minus a to the power of 3 by 4. Now you see that you have the numerator but the denominator is missing, and in both of them the denominator is same, x minus a. So what we will do now is we will divide both numerator and denominator with x minus a. So that becomes x to the power of 2 by 3 minus a to the power of 2 by 3 divided by x minus a divided by, you will have x to the power of 3 by 4 minus a to the power of 3 by 4 again divided by x minus a. Now you know by the rules of limits, or say properties of limits, limit of quotient is nothing but quotient of limit. So I can write them as separately. I can say limit x tends to a, this is nothing but equal to x to the power of 2 by 3 minus a to the power of 2 by 3 by x minus a divided by limit x tends to a, x to the power of 3 by 4 minus a to the power of 3 by 4 divided by x minus a. So this is nothing but equal to, now what is the value of n here? N is nothing but equal to 2 by 3. Here n equal to 3 by 4. So let's substitute that. The formula is x to the power of n minus a to the power of n by x minus a is n into a to the power of n minus 1. N is 2 by 3 into a to the power of n minus 1, that is 2 by 3 minus 1 divided by, here also n is 3 by 4, n into a to the power of n minus 1, that is nothing but 3 by 4 minus 1. Now we have to simplify this. This is nothing but equal to, can I say 2 by 3 into 3 by 4 will become 4 by 3, because when you are dividing you want to multiply, you should take the reciprocal of that, and I will have a power 2 by 3 minus 3 by 3, that is minus 1 by 3 into 1 by a power 3 by 4 minus 1, that is nothing but a power minus 1 by 4. So this is nothing but equal to 2 4s are 8, 3 3s are 9, into a power minus 1 by 3 into, I will make this as positive so that I will bring it up, it becomes positive. You know that whenever you have negative powers, you want to make them positive, shift them from denominator to numerator or numerator to denominator as needed, because 1 by a to the power of minus m is a power m. Okay, now if you simplify this, this is nothing but equal to 8 by 9 into, you have the form of a to the power of m into a to the power of n, that is nothing but a to the power of m plus n. So that becomes 1 by 4 minus 1 by 3. If you take LCM and simplify that, this becomes 3 by 12, this becomes 4 by 12. So your answer will be 8 by 9 a to the power of minus 1 divided by 12. So in the next session, we will solve some more examples on this particular concept. Limit standard result number 1, x to the power of n minus a to the power of n by x minus a as x tends to a is equal to n into a to the power of n minus 1. So that's what we are going through, and we'll continue some more examples in the next session too. Thanks for your time. Bye for now.